Hi everyone, let's look at yet another LeetCode question. This is problem 226. Invert binary tree. Given the root of a binary tree, invert the tree and return its root. I'm not quite sure I understand the problem here. Given the root of a binary tree, invert the tree and return its root. Okay, let's look at the examples there. Examples 1. 4271369 becomes 4729631. Okay, so it's basically inverting the left and right. By invert, it means inverting the left and right joint, such that the left becomes like right joint and the right becomes left joint. Okay, I think that makes sense. In examples 2, we have 213 becomes 231. Also makes sense. Okay, let me just write it down here. So given the root, we 3 root invert and right side. So examples 1, we have 4, 3, 7, 1, 3, 6, 9. Then this would become 4, 7, 2, 9, 6, 3, 1. Okay. Second, 2, 1, 3. Now this would become 2, 3, 1. Example 3, it is an empty, so we just return empty. Okay, I think I understand the problem now. May I ask a few clarifying questions? First one is let's see. There's not much to clarify here. The number of nodes can be 0, which is obvious, you can tell from the examples 3. Okay. Alright. Right now, I will try to come up with possible approaches for this. I think this is quite straightforward. What we can do is we can use So we could use the recursive, and then every time we reach a node, a tree node, we basically invert the left and right track, and then we move on. So let me just write it down here. Recursively. Invert, and then two, one on track. Okay. The so like for a okay, let me try to uh, do this on our examples given. So first example we have 47, 1, 3, 6, 9, and then in the first one we have 472. Okay, and then we go on to the, let's say, the left node. Then we will invert it into 3, 1, and then also do the same one, 9, 6. Actually, it would looks like 3, 1, and 9, 6. So 472, 3, 1, 9, 6, 3, 1. Okay, that's correct. Second one we have 2, 1, 3. Then that would just be 2, 3, 1. Third example, we have empty, so we just do nothing. Okay, now does this sound reasonable to you? I'm pretty good about this, and I would like to start coding unless you want me to explore further optimization. Sounds good. So let's proceed to coding. Here, let's see what we got. Input 3. Then we have root. So what we're gonna do is we check if the root is null or not. If not root, then we're just gonna return. Else, we would do the operation as above. Root dot right, root dot left, root left, root dot right, and then invert 3 on root dot right, and also the same thing on dot left. Okay, do I need to return the root? Yeah, so we need to return the root. Okay, I think I got the solution here. Let me see if let me go through the code again to see if I missed anything. So first of all, I check whether the row is empty or not, and then I'm gonna invert the child nodes. At this point, we have done the current three nodes done, but we also need to invert all the child nodes. So I'm gonna do it recursively by calling the same function with input on the child node. Each call is for the left and right child. And then at the end, once this is done, I will return the root. So I think this should work. Let's test it with our examples that we are given. So we have 4 to 7. We input the chart. So we have 4, 7, 2. And then we go to the left side. We have let's see, 6 and 9. So we invert it into 9, 6. And then at this point, the chart will be none, so it will just return. And then also we need to do the same on the right side, which has value 2. So we have 1 and 3 inverted, that will become 1. So that completes it. Second example, we have 2, 1, 3. Inverted, we have 2, 3, 1. Then the last one, we have empty, which is just none. So we just return the right way. Okay. Now let me try to put this into LeetCode to see if we have any problem. So if not root, let's just directly use it. Right, left, left, right. Let's try to run it. Yep, we got it correct. Let me try to submit it. Hopefully we got it correct. And yes, we did. We got it correct. I think we don't need to look at I think pretty much everyone is doing the same thing because it's quite straightforward. Everyone, let me stop here. Thank you.